Hello, this is Anis Ada. Welcome to my YouTube channel. For our first video, we are going to look at area of triangles. Remember, we have different type of triangles. We have rectangle triangles, isosceles triangles, scaling triangles, and even equilateral triangles. Well, for now, we are going to look at the area of a rectangle triangle, and we have it here. And there is one special thing about rectangle triangles. You find that the base and the height, they intersect to form an angle of 90 degrees. So if you're trying to get the area, you just say that the area is given by half times the base times the height. Now, sometimes students are given triangles which are inverted. So how do you get to identify the base and the height such that you don't use the hypotenuse? This is how you identify the base and the height. The two lines that intersect to form 90 degrees, those are the ones that give us the base and the height. And our base in this case is 6 centimeters and the height is 8 centimeters. Therefore, I can just write half times 6 times 8. And I can cancel these two and this one to give me 4. And then I'll be having 6 times 4, which is equivalent to 24 centimeter squared. And I've gotten my area. And in some instances, you find that the student is given the hypotenuse and maybe the base, and the height is not given. Well, in such a case, the student is supposed to use Pythagoras theorem so that you can get the base and the height. So that marks the end of our first triangle here, which is right angle triangle. Okay, let's look at this other triangle here. We find that we have triangle ABC and we don't have any two lines intersecting to form an angle of 90 degrees. That means we cannot use half times base times height. But there is one thing about this triangle. These two lines, AB and AC, have been given. We have the measurement of the two lines. And again, these two lines are intersecting to form an angle of 40 degrees. So we can use another formula by using the two given side and the angle here. And the formula is our area here will be given by half AB times sine theta. So how do we get our AB and theta? Theta is the angle between the two given lines. So in our case here, we can use this one as our A and this one can be our B. So the angle in between A and B, that is our theta, and in our case, the angle is 40 degrees. So we are going to get our area as half times 35 times 30 centimeters times sine of 40 degrees. And then we get our final answer here. Then another thing, sometimes you may be given, let's see, BC is 33 centimeters. If you're given 33 centimeters, 30 centimeters, 35 centimeters, how do you get the area? You use the same formula. You use half AB times sine theta. Again, I want to insist on this. AB are the two lines that intersect to form an angle which is already given. So we can use 30 centimeters, we can use 35 centimeters as A and B, and then this angle here. We cannot use half times 30 times 33 sine 40. That is very wrong. So always use theta as the angle in between the two given side. So the answer to this one, half times 35 times 30 times sine 40, we can cancel this one. giving us 15. And then we are going to have that 5 times 15 times sine 40 degrees. If you use your calculator, you are going to get your answer as 337.46 centimeter squared. So that's how you get the area of a right angle triangle. And even for this other triangle,